For this configuration, this is just the basic configurations. The basic configurations help us to understand the basic requirement for the to configure a controller, and also second part we have a network setup configuration example. Let's see one by one. First one is the configuration of the interface. We can configure an interface into layer 2 access mode. It's the same in the switch, like switch mode, switch port mode access, and the switch port access VLAN 10. So this is the layer 2 access mode. And then if you configure one port into the access VLAN 10, and then if you want that IP want to connect to what use that port work as the DHCP server, you can enable you can create a interface VLAN 10 and have an IP address for this interface VLAN 10, and also keep enable DHCP servers. And also you can configure interface into the layer 2 and the truck. Also you can configure interface into the layer 3. And in the layer 3 interface, we can enable the DHCP servers. This is how we enable the DHCP servers. For our DHCP server, it can be a DHCP server or it can be DHCP relay. This is the enable the DHCP server in the VLAN interface. We just click, you just enable the DHCP server and end the policy. In the policy, we create the DHCP pool. In the pool, we configure the IP range, DNS, these parameters for DHCP server. Then if you create a SSID, if you want this SSID have this specific VLAN, so we just assign the VLAN to that SSID. Now let's go to see the routing. For the routing, first one is the direct routing. Direct routing is like we have an interface, you have a layer 3 interface, you configure IP address, then it will have a directly connected routing. And you can see it from our web console. We just show routing, and here all the IP address that in the physical layer 3 interface or the virtual SVA interface as the VLAN interface. This all we consider as directly connected routing. This one is universal to other vendors, just like this is the universal protocols for the switches and controllers. Directly connected routing is the subnets or the IP address that directly connected, configured in this device themselves. So this is direct connected routing. And then it's a static routing. If we want to configure static routing, we can use the in the wired networking, and you end a static routing. For the static routing, it can help us to do the communication between the different subnets. For example, we have our devices going to another another subnets, another device, but this is not our directly connected subnets. So we need to tell them what is next hop. So we go to the after you configure this one, you go to the web console and you type in the root, and you can see that this static routing can be reached by the 90 to the 160.10.254. This is next hop of this VLAN interface 10. So this is the static routing. And also the default routing. For default routing is the routing we almost used in lots of our projects, because for our products is in the enterprise or smooth. Usually we just want default routing. So default routing is when our devices receive the traffic, and we just forward it to the next gateway. For example, the firewalls or the core switch. So we just have this default routing that match all the destination subnets. So the next hop, we just give all the traffic. You can see that. Also, you can find it in our web consoles. So default routing actually is a static routing. It is also a static routing, just a very special one. It includes all the subnets. That's why it's a policy-based routing. Policy-based routing. What the purpose of this one? So we know that for our common routings, like the ordinary routings, the forwarding is based on its destination IP address. Just based on the destination IP address. If their IP address is this one, I check the routing table and I match the routing. If maybe this is a static routing, maybe it's just a default routing, and I forward the traffic. The policy, like in some client maybe have requirement. For example, the first picture, we have the two ISP. We have two ISP. So they want the user group 1 going to the ISP 1, and the user group, for example, this is another department, the department of the engineers. They want they want this group of users to go to use the ISP 2. So we can use the policy-based routing to achieve this purpose. And also another one, like in our client network, we use some Sundray's controller, and the one controller directly, they have one ISP directly connected to the controller, and another cable going to their intranet. For the guest Wi-Fi, when they connect to the AP, and the traffic go to our controller, and then directly go to the internet. But for the staffs access, for the staffs, when they connect the Wi-Fi, their traffic need to go to their core switch, maybe reach the servers in their intranet. So in this situation, we definitely need policy-based routing. So for the policy-based routing, it can be based on the source IP address, destination IP group, also the protocols. For example, if you want to visit the HTTP, you want to the traffic go to the websites, go to one servers. The traffic go to another FTP servers, go to another ISP. So based on the protocol, they choose the next hop. And one thing we need to know is the priority. The policy-based routing priority is higher than the static routing. Also the other normal routings. So when we receive the package, we check the policy-based routing first. If we have policy-based routing, we just follow the rule made by the policy-based routing. We forward it to the next hop. If we don't have the policy-based routing, then we use the static routing. The match rules is from top to the bottom. From the top to the bottom. So this one can. It's just like we have several rules. It will match the top one first. If the top one doesn't match, go to the top two. Top two, go to top three. So this one we can use for the backup, right? For example, if we have the two oblique, if the first one, we match the first one. If the first one is not reachable, so we can go to the second one. So from the top to the bottom, you match it one by one. So this is the rule. Also can give us idea to do the backup for the oblique. So here is the configuration. When we do the configuration in our controller, first we need to do the we can configure the IP group, because this IP group is the we can use in the source IP address. For example, for the guest, we are using the IP address from the 192.168.101 to 120, right? That is staff. When the staff connect to the Wi-Fi, we go to the another hop, one different one next hop, and we have the another group of users. We go to another next hop. This is policy-based routing. So here's that if there's a requirement to distribute the traffic based on the access point, you can identify the VLAN rule based on the access point in SSID, and then do policy routing based on the source IP address to achieve the traffic distribution. Now let's together we do a configuration for network together. So here is the you can see that is current network. This is the current network. You just have the switch. So one switch, one router. They don't have the wireless network. They don't have this WLAN. The requirement is have a WLAN, just a simple authentication. Just for example, PSK, and the client purchase our controller. So how we can do the configuration? This is our setup. We buy 1 hour controllers, and then they give us one cable and also the APs. So this is the plan of the IP address. They give one IP address to our controllers on the ETH1, and also the ETH2. We can work out our own subnets, because our controller will do the net. This controller will do the net, and then traffic be set to the switch forward to the Ethernet. So later we state how we can configure the one step by step. I think these terms you already know that AAC, we call the Sundray controller. Before we have the identifier for this one is the Sundray access controller, but right now we call the network administration controller, because this controller can manage the AP and also the switch. So it's not like before it's the access point controller, but right now it's administration controllers. And the APs, access point, SSID, Wi-Fi names, PoE, power over Ethernet, stations, the laptop. Sometimes we call it endpoints. Sometimes we call it the terminals. Sometimes we call it stations. Sometimes we call it clients. The same thing. And now we see the first we configure interface if you want to set up that network. So ETH1, we know that it connects to the switch. So we give the IP address to these controllers ETH1 port. And for the ETH2, we will connect to the APs. We will connect to the APs. So we can configure the layer 2. We can configure the layer 3. We can configure the truck. We configure access. It's very flexible. So here I chose to configure it in the access and the VLAN 1. And in the VLAN 1, I enable DHCP server. Why I enable this one? Because in the ETH2, maybe other ETH2, I would connect a manageable switch, right? I just configure a switch. I connect the switch. Under the switch, I connect lots of the APs. So the AP need the IP address. So I enable the DHCP server in the VLAN 1. So when the AP connected to the ETH2 or the switch, other ETH2, it can get IP address. There's one thing we need to know. Sometimes we do the troubleshooting because of these settings. Advanced setting in the VLAN interface configuration. There's the Ether VLAN routing. Defaultly, Ether VLAN routing is unchecked. inter VLAN routings are checked. So sometimes we cannot, like for example, from this VLAN to another VLAN, we cannot pay each other. But there, we say that our controller support the over VLAN routings, right? So that's a problem. So we needed to, sometimes we needed to open, if we have requirement to do the communication between the different VLANs, we need to check this one. This one also in some, when we do the net, especially for the port mapping. For example, our controller working as the gateway in some servers. After you do the netting from one port, go to the inside. Right, at that time we need to enable this inter VLAN routing, because sometimes we did the right configuration about port mapping. Just because we don't check this allow inter VLAN routing, the port map is not working. I mean, the traffic can go to our controller, but our controller cannot set to the VLAN, to the servers in that specific VLANs. So after the DHCP, we enable the DHCP server in the VLAN 1, and now we need to configure the routing because we here we just configure one default routing is okay. All the traffic come from the AP. We forward it to the routers. We forward it to the switch. The switch is just a layer 2. So the gateway is router. We just send it to the routers. So next hop is a router. So after routing, we also need to configure the net. If we don't configure the net, we need to configure the routing, comeback routing in the routers. We need to configure that route, back route in the routers. So here we choose to configure a net. Actually, lots of the project for the Wi-Fi project, we choose to configure net because that is more convenient. If we don't use a net, we need to let the clients, the customers, IT to configure the routing for us. For example, we create the VLAN 1, the subnets. We create that subnets. So they need to add that subnets in their network. So when our traffic go to their network, they can set back for the reply message. They can find our devices. So if we don't do the static routing in the user's devices, we just use the net. So our controller support net. And also we can check the DNS and the test because our controller need to go to the internet to make sure the DNS is correct. When you do the test, if you want our controller work as a DNS proxy, you can just enable to check it. And then is in the web consoles, you can do check the internet connection. Sometimes you can check the communication with the APs. So the web console is very useful tool when we do the troubleshooting or verify our configuration. And then is find the APs in the controllers. For the AP discovery, we have the 4 ways. Later we have the detailed explanation. But right now, just like the controller find the APs because right now is the APs directly connected to the controller. So it will be discovered automatically because they're in the same layer to subnets network, you can say. So once this AP be discovered by the controller, we approve this AP. After we approve this AP, we put this AP into a specific group and give this AP a name, especially when we do the project. Because this part is very important. Because you don't mark the position or don't give the name to these APs, you think you have 10 APs, and you put it in a different place. After that, you don't know where is that specific APs. Some APs offline. You don't know that where's this AP. So after that, this AP will be online. So you can check it from the WLAN standards. Use standards, you can monitor like its channel utilization. If that AP in the environment that have the heavy interference, this color will be turned to the red. So we all love the color of the, yeah. In this page, we love the gray. If this color is gray, that means there's the interference. This environment is very low. Is the relative low. Is a good wireless environment. So after the AP online, and we can create WLAN. That's mean the SSID, a Wi-Fi. We can create a Wi-Fi. So with this Wi-Fi, we go to the authentication, and just for the, we just choose the PSK because this is just a very basic one. Later, we have the authentication methods slides for different methods. So here just a PSK. We can data encryption. We can use the AES or TKIP, two methods, and yeah, also can choose the auto. For me, usually I choose the auto because some devices maybe only support ASC, some just only support TKIP. So support when we configure the auto, this like this Wi-Fi is more compatible. And then we can assign the VLAN to the users. Remember here we are using the tunnel mode. So we assign the VLAN 100 to the users. Before we also created the VLAN 100 for the guest Wi-Fi because we assign this VLAN to the guest when the users connected our Wi-Fi. They are in the VLAN 100. So make sure in the VLAN 100 we have a DHCP servers. If we don't have DHCP servers, when the user connect our Wi-Fi, they cannot get IP address, so they will show that failed to obtain IP address. So after this, you can say that you can check the station's information from our controllers. You check if they're successfully connected. If they're connected, you can say that the IP address, a MAC address, IP address, and also the VLAN, which VLAN there. So this is the configuration for this very simple network, but it's already explained all the things we needed to do for we set up SSID with controller and APs.